Vector plane is for the two-dimensional, okay, where you have the plane. This is the plane of xy. Okay, suppose that you can name the vector as vector v is equivalent to ai plus by bj. Now a here is the horizontal component, b here is the vertical component. I and j is a unit vector with respect to x and y axis. Okay, so let's say this is your I, this is your j. So what you have over here is actually a scalar multiplied by a unit, means one unit of a unit vector of I, then b also is a scalar. Alright, so this is your vector v. Now, this vector v also can be written as in this form, where you put in a triangular bracket of AB. This also means a vector. Okay, so that's how you represent your vector in the plane. Okay, now, if you remember back in your trigonometry and your complex plane before, okay, what you can see that you're going to have the similar kind of diagram, where this particular part would give you a diagonal part that can represent a hypotenuse, where you can actually have a triangle from here. So you can have a triangle from here. Alright, if you look at here, you can have a triangle. So this part, now this length, we can name it as magnitude of v. Okay, instead of you put the radius or the hypotenuse, for vector, we name it as the magnitude of v. Now, what is the magnitude of v? Magnitude of v represent as, in the modulus of v, equivalent to your Pythagorean theorem, where you're gonna have this component is a, and this length or the component here would be b. Right? So you will have a squared plus b squared square root. What else can you know from the diagram? Right? Another thing that you can know from the diagram is this, where you can have an angle. Now this particular angle, we call it a direction angle. Now again, your direction angle always depend on the quadrant of your vector. The angle that you can find over here is your reference angle, where the acute angle having the inverse tangent or arctangent of y component, which is b over here, over by the x component is a. So this thing you have seen like a lot of time already, so I hope that you still remember. Now, another thing that you can know from this diagram is the horizontal and vertical component. If you want your horizontal component, which is the a, is magnitude of v cosine theta. Okay, horizontal component. Now for vertical component, b is equivalent to magnitude of v sine theta. If let's say you want to write your v here, your vector v of a I plus by bj in terms of magnitude and direction angle, you can always write as magnitude of v cosine theta I plus by magnitude of v sine theta j. Magnitude v is the common term where you can factor out. You're going to get cosine theta I plus by sine theta j. Okay? Now let's look at one example. Let's say given v is negative 4r plus 4 sec 3j, find the magnitude and the direction angle of v. So to find the magnitude, now use your formula of Pythagorean. So magnitude, now I mentioned just now is a modulus. Now this not mean a modulus, okay? It's just a representation of magnitude of v. So equivalent to your a squared plus b squared square root. Now this will be your a, and this would be your b. So substitute into the formula, you're going to get negative 4 square plus by 4 set 3 square root, which you can get equivalent to, you will get square root of 28. Or you can also simplify as 2 square root 7. Okay, this is your magnitude of V. Now the direction angle for V, look at which quadrant does it fall first. Now for V, be negative A and a positive of B. Now this one would be fall at quadrant 2, correct? This will be at quadrant 2. So because it falls at quadrant 2, now this is your V. Okay, now your real theta or actual theta is here. Okay, so what you know is your reference theta. So you must subtract from the 180 degrees minus by the direction angle arctangent or inverse tangent of B here for set 3 over by negative 4. Okay, now since you have this one is a modulus, so when you calculate, you're gonna get 180. This would give you 60 degrees. So which gonna give you 120 degrees. So this is your direction angle for V. Okay. Now let's say if the question asks you to write your vector in terms of magnitude and direction angle, so you can write it as such. The V can be written as such. The 2 square root 7, which is magnitude V. The cosine theta is 120. I plus by sine 120 J. Okay, as simple as that lah.